Okay, welcome to IA 101, or I'm sorry, IA 107. I call this course Shop Math in kind of short term for it. It's really focused on making sure that all the students who come into the mechatronics program or other trades programs have a basic set of skills. I want to make sure that when you get out onto the shop floor, you get onto my lab floor, you've got some basic skills and you know what you're doing. So a lot of what I'm doing in this class is trying to assess where the class is and make sure everybody is brought up to the same level. We're starting off with measurement systems. Measurement systems is the first part of this course. And today we're going to talk about a whole range of measurement systems, some of which you're very familiar with, some of which you may not be. So we're going to start off talking about rulers and what I call linear measurement systems. We're going to hit on rulers. We're going to talk about tape measures. We're going to talk about some of the more accurate and more high-tech versions of these things that are used in machine shops, and they're calipers and micrometers. Blanking out a name. I had to go look at the name on the case. Calipers and micrometers. So we're also going to talk about measurement systems which are used in a broader sense across the shop, which are measuring other things besides the distance of something. And we're going to talk about temperature, pressure, voltage levels, and other things such as a current demand, things like that. And we're talking a little bit about flow rate and some other factory features. Now, I don't have any flow meters here in my little demonstration area, but we're going to talk about how they work in general. All of these systems fall into two categories. The two categories are very simple. The first category is the old school category. This is when you've got a physical device with calibrated lines on that device. That means they use some sort of precise methodology to lay out lines, either in a ruler like this, straight along the edge, or carefully calibrated lines like this one. This is for pressure. So this is a pressure gauge, and its lines are going in an arc. They're wrapping around a pivot point, which is the needle, which shows you what the actual pressure is. So both of these are pretty much the same. They're both old school methods of showing a measurement system. And they require a little bit of experience in understanding how to use them properly. Of course, in the modern era, we are now more and more looking at digital measurement systems, in which case you don't need to have any kind of great experience in using them. You can just read the number right off of it. But it still helps to understand how they work, and partially what we do in the whole mechatronics program is teach you how these different systems work. Not in this class, but in future classes. You'll be learning how these different systems work. And so this class, we're going to start off with just the idea of measurement and the kind of ways we measure things. Number one, linear measurement. All of you are familiar with a steel rule. A steel rule or a plastic ruler or other kind of rulers. Here's my favorite. This is a modern version of a ruler that I used to borrow my dad's version of this and then use it for sword fighting. And then, of course, I think it broke and he was very sad. And now I'm very sad because it was a beautiful antique ruler made of wood and had brass caps on the ends. It was wonderful. But I've got this plastic version, which essentially is a 200 centimeter version. It's almost 79 inches long, foldable linear ruler. So that's a pretty cool thing. So let's talk about how we use these things, because there's a few features that I kind of want to go through and how to use them. I guess I need to make that less glary. There, that's better. All right. So most people understand how you use a ruler. You think about the increments between each one of these numbers. So between 13 and 14, I see a series of increments. So I've got the tallest of the increment is halfway between, and that's 1/2 of an inch. Then there's a second tallest, that's a 1/4, and I have 2 of those on each side of the 1/2 inch mark, and that's a 1/4 of an inch. And then the third tallest is an 1/8 of an inch, and the smallest is a 1/16 of an inch. And I know it's a 16th because I can count 16 of them between 13 and 14. So that's a pretty basic understanding of how you use a ruler. So what is the accuracy of a ruler? Can anyone guess what the accuracy is of this ruler if I'm measuring between 13 and 14 inches? Probably, if you wanted to guess at it, you'd guess a 1/16 of an inch. But the truth is, a good machinist can do a little bit better than that, because if they find that their measurement ends up somewhere right between 13 and 14, roughly between 13 and 14, then they can interpret that it's going to be somewhere between, say, 3/16 and 4/16. They can convert that to 6/32 and 8/32, and they may write down 7/32. So they can use those two marks and interpolate a mark in between. So you can get a slightly better accuracy than just purely the mark. Plus, on this ruler, if you look at the end that's closest to the 1 inch mark, they do have 32nd inch marks. So that if I wanted to, I could make my mark where that 13 was, or 14 was, and then I can slide over my 32nd marks, and I can get a more accurate reading using this ruler. A key part about this ruler is this ruler doesn't start at 0. I can't butt this ruler up against something and start measuring there, because there's about a little less than 1/8 of an inch mark area on the end of the ruler that's not part of that measurement. Same thing with this ruler. This ruler, however, because it's used to measure inside of walls and squares and things like that, its 0 mark is right on the very edge of the ruler. So I can use this ruler and butt it up against something and start measuring from there. So this is a more effective ruler. So knowing where the end of your ruler is very important. A lot of rulers come with multiple unit of measures now in the United States. For instance, this one has centimeters on one side, actually millimeters and centimeters on one side, and inches on the other. So it's useful for a variety of different kind of projects. Same thing for this one. This one also is a specialized ruler. This is doing for layout work. This is used for layout work. It's got a little magnifier built into it. It's got lines of text increments built into it, so that I can do layout of text work on, say, if I'm doing some printing work. So this is a specialized printing ruler. This being a plastic ruler is not ideal in my world, because I'm hard on all rulers, and see, this is already broken. So I like stainless rulers. This ruler right here is an architect ruler, and we have some of these in the classroom. And these are very special rulers because they don't always use traditional 1/4, 1/8, 16th, 32nd of an inch increments. You know what the increment is because that edge that's marked with the increment, it tells you right there. This is 16. So that means each one of these little marks is 1/16 of an inch. But if I turn the corner, I can see now I've got a ruler where each mark is at 3/4 of an inch. So I've got 1 3/4, 2 3/4, 3 3/4, 4 3/4. If I'm doing scaling work as an architect, this is a very useful measure, right? Here's another on the other side. This one's got 1.5 inch increments. So this is 1.5, that's 1.5, that's 1.5, and so forth. So if I'm going to use it like a regular ruler, I want to find something that's got a familiar unit of measure in it. This is also useful if I want to look at things in, does this have a tenths mark on it? This one does not have a tenths on it, but it does have a variety of different odds and ends scaling. So that's just something useful to know. So knowing when the start of a ruler is also is important when it comes to tape measures. A tape measure is nothing more than a ruler that's flexible and rolls into a container. A tape measure has a tip on it, which changes the starting position of this ruler. If I push down on this tip, then the 0 is on the outside edge of this little steel flange. If I pull out on that tip, then the 0 mark is on the inside edge of that steel flange. What if you drop this tape measure and you bend this steel flange? Well, guess what? Your 0 is screwed up. And as a matter of fact, it looks like I dropped this. It's got a little bend to it. I think I got to fix that. All right, so this tape measure can be inaccurate if I'm not careful with how I handle this tip. And it's designed to move back and forth so that if the inside measurement is going to be a difference of the thickness of this flange versus the outside measurement. There's other kind of tape measures. This is a long distance tape measure, and its 0 mark is set up to be pretty precise. If I fold it in like this, I can have a nail through that hole, and then the 0 mark is right at the outside edge of that nail. If I flip the little flange out, it's got a little spiky, grabby flange. I can hook this over a stake and it pulls into the stake a little bit. Then my 0 mark is on the inside of that flange. Now, this ruler is not expected to be super accurate, but this is a common ruler used for layout of small buildings up to 100 foot. So this is a good layout ruler from Stanley. This is a steel ruler. There are tapes that are longer than this that are made of fabric, like a nylon material. So those are examples of rulers. Some of them are flexible. Some of them have adjustable tips where you can, depending on how you set it up, your 0 point's different. And they're all designed for different applications. In the mechatronics world, I recommend highly that you have a tape measure as a minimum, a steel rule, a 12-inch rule, and a 6-inch rule. I would suggest the 6-inch rule is the most useful because it measures small things that you can keep it in your pocket. So a small 6-inch rule is useful, and these are all very good. All right, so I'm going to pause. All right, we'll resume recording. Now we're going to talk about tolerance. When we talk about tolerance, this tells you what the accuracy needs to be. Let's say I tell you, go cut me a piece of pipe 5 inches long. Right? Are you going to go cut that pipe if I just say 5 inches long? Well, maybe you will, and you'll get as close as you can. And maybe 5 inches plus or minus a 1/16 of an inch is good enough. But most times in the machine shop world, that's not going to be good enough. I have to give it a tolerance. I have to give it an accuracy. A tolerance is usually a plus or minus value. Sometimes there are different values. Sometimes it might be plus something, one number, and then minus something, a different number. That plus or minus tells me the tolerance that I can have this off 5 inches. Because if I just go cut this on a chop saw, 5 inches long, it's not going to be exactly 5 inches. There's no way to get exactly 5 inches. I might say plus or minus 0.01 inches. That is my tolerance, plus or minus 0.01 inches. If I have a 1/16 of an inch accuracy, is plus or minus 0.01 good enough? Does anybody know what the decimal equivalent of a 1/16 of an inch is? No, let's measure it out. 1 divided by 16 is 0.06. So if I have a plus or minus 1/16 accuracy, that's 0.0625. That is bigger than that. That means that I will not be this accurate if I use a normal ruler with a 1/16 of an inch accuracy. So this won't work, right? So now we have to get down to different devices that give you better accuracy. So one of the most common ones is something called a caliper. And there's a couple different kind of calipers out there. And we'll be learning how to use these properly, so we're not going to spend time learning how to use them. But in general, these guys have a higher accuracy. And I'm going to switch this to inches. All right, I had to switch it to inches. This is a digital caliper. So if I want to measure 5 inches with this, it's got a 6-inch caliper. So now I can measure out 5 inches really, really accurately, down to 1/1000th of an inch. Can you see the number? No. So at 0.4999, do I have my tolerance covered? Yes. I'm only off 0.001. So it's way more accurate than it's shown there. So now if I mark my part and cut exactly to that mark, I know I'm going to achieve the accuracy I want. Now, we also have a different manual caliper, the old school caliper, which I'm not going to get into that, but you can do the exact same measurement as you can with the digital. This will give you the more accurate measure for machine parts. And if you want to get more accurate than that, then we get to the next linear measurement tool, which is the micrometer. And we pop open my micrometer case. And I always keep these in padded cases, because if you drop them, then they can get damaged and they long. Now you've got even a more accurate measurement system. They have digital micrometers as well. They tend to be better at measuring very small measurements. This is a 2-inch micrometer. I've got a 1-inch, 2-inch, and a 3-inch. And I can get extremely accurate measurements with this micrometer. And we'll talk about how to use them at a future class. So all these are linear measurement systems, and all of them are going to give you an accuracy measurement. All of these are set up to be either inches, or like the case of the digital device, it can flip between inches and millimeters very easily. In the in Europe and in Asia, and in fact almost everywhere else in the world, you're going to find that they use millimeters as the common measurement for most drawings and most devices out there that are linear measurement systems. So millimeters is the most common. Zoom recording. All right, so let's talk about another measurement system. Air pressure. Air pressure, or any kind of pressure, pressure of hydraulic systems. Pressure is a measurement system, and what happens in any kind of measurement system like pressure or flow, they convert that physical situation, this flow rate or the actual pressure in a system, into some sort of mechanical movement, which then in the more advanced systems is then converted to an electronic movement. Some of the early pressure gauges look like this. So some of the old school folk out there are like, yeah, I know that pressure gauge. And when you jam this end against the stem of your tire, it pushes out a mechanical bar, and there's a little flow in here. So depending on the pressure, it's going to keep pushing this out until there's like a little aperture inside here that gets narrower further it goes out. It'll keep pushing this out until it equalizes. And then when it equalizes, you can read the little stick here to tell you what your pressure is. And once again, you got increments between measured marks. So in this case, the increments are really obvious. They're 1 pound increments, 30, 31, 32, 33, 34, 35. Easy to understand those increments because they're 1 pound PSI increments. Do I have an accuracy of less than 1 pound? Yeah, but this is such a primitive mechanical device, I probably would be happy if it were plus or minus 2 pounds accuracy. But for years, this is the kind of thing, since the 40s, I think, maybe earlier 30s, this is the kind of pressure gauge we would use to measure the pressure in the tire. Nowadays, we have much fancier gauges. A pressure gauge you're going to see in most shops is going to look like this. This one is going to be more accurate for you because it's continuous and you don't have to press it on something and release. I can adjust. This is a regulator with a gauge on it, so I can adjust this. I can pop this up. I can adjust the dial, and then I can change the pressure, and I can see how the pressure changes here on that particular dial. These dials, we're going to learn more about them later, usually have at least 2 unit of measures on the dial. This dial has got a unit of measure on the outside. It's in black, and then the little black number below that. I don't know if you can you guys see that clearly? You probably can't. It says PSI in black. And then we've got an inner dial, which is red, and then it says KPA, which is kilopascals, which is your European unit of measure for pressure. We're probably going to stick to PSI, pounds per square inch, in this class. And this one actually would seem to be less accurate than our little tire pressure gauge because my increments are relatively few. Let's say between 0 and 20, I only have 2 increments. So by seeing 3 segments between 0 and 20, or 2 segments between 0 and 20, I'm not even sure. I guess that's supposed to divide that into 3 segments, 20. So it's roughly 7 point something. And then between 20 and 40, I have 4 increments. So I assume that's 20, 25, 30, 35, 40. So I can look at my increments and figure out what they mean based on the 2 numbers on each side of those increments. But that means I really have closer to a 5 PSI accuracy on this meter as opposed to a 1 PSI accuracy on that tire gauge. Should I believe it? Probably. Usually gauges like this are not designed to be super accurate. They're designed for hand air tools, things like that. So they're not super precise. And this is a hose off of one of my projects. So pressure is another area that you're going to run into. Gauges themselves are an area you're going to run into. You're going to find gauges used in a whole bunch of the older systems out there. However, in modern systems, you're going to see always some sort of digital measurement system. So, for instance, let's go into a modern system. A lot of times people are worried about power consumption. So one modern measurement system that we have put into play is the ability to measure voltage and current. Let's say if I unplug my lamp here and I stick my lamp into my current meter. All right, now I've got my current meter. There it is. I put my current meter in the lamp. So I can actually see how many amps are running through that lamp. So in many cases, we want to monitor power. In this case, they're almost all digital. However, there are old voltmeters and systems that measure these with dial gauges as well. And obviously, voltmeters have come a long way. This is an example of a graphing voltmeter. So I can be measuring the actual, I can see the actual graph of my voltage. I can see, the sine wave of the voltage coming down the power line. So we can go a long way. And this is all digital now as well. So all of these are digital systems for measuring voltage and current and that sort of thing. So we've got our lamp there using up 0.13 amps at 120 volts. And that is a very simple thing. Now, all of those are in a simple digital format, and the accuracy is implied by the units you see on these devices. So if it's 2 decimal places, we assume that's the accuracy. However, you should always check the specs to find out what the actual accuracy is. The last measurement system I'm going to talk about is temperature. in our sensors class, we use these little guys. These are infrared temperature sensors. I think the whole world has gotten used to these when the COVID thing came out. They actually are also digital as well. And by pointing and shooting, it gives you a reading that is collecting data out of this end. It sort of takes an average temperature measurement across an aperture, and it'll give you a temperature range. A more accurate temperature measurement system might be this guy right here. This uses thermocouples. So I would plug in a thermocouple, and I would power this up. Oh, look, the battery still works. How about that? And the thermocouple would give me a measurement right here at the tip of the thermocouple. And it can be automatically converted to degrees Fahrenheit, degrees Celsius, to whatever I want. I can adjust its reading. So it's a really powerful device. And if I warm this up, you can see the temperature goes up just by putting my finger on it. This is a very accurate system. And this particular device not only does temperature measurement, but it does data logging. So I can actually record a log over a time period and then download that to my computer. This is an example of a measurement device with extra features built into it. And from a temperature world standpoint, there are a lot of different kind of temperature measuring devices out there. This is the kind of one you would use as a technician to go out onto the shop floor. So I just wanted to introduce you to some of the core concepts around measurements. So let's do some unit of measure conversions. If I tell you that I've got something that's 3.5 inches, now you guys are all familiar with this little 2 hash mark thing, right? That means inches. If I put a 1 hash mark, that means feet. Okay, how do I convert that into centimeters? Well, first thing I'm going to do is show you how I would cheat. So what I'm going to do is share my, open up a screen, and I'm going to share my screen with you. And we're going to go to Google, and you're just going to type in convert 3.5 inches to centimeters. And bam, Google does it for you. So this is my way of cheating. 3.5 inches is equal to 8.89 centimeters. Now, if you knew that, as somebody said earlier, 2.54 centimeters per inch, I could just do that multiplication. I can multiply 2.54 by 3.5 and get that 8.9. But if I don't have a calculator handy, but I do have a little Google handy, I can get it instantly like this. Another way of doing it is you can open up your book. And here in my pocket reference, I've got conversion tables where it says convert from into. So I want to go from inches to centimeters, GHI, inches to centimeters, I multiply by 2.54. So I convert from inches to centimeters, I just multiply 3.5 by 2.54, and then I get that same answer that Google gave me, which is 8.89 centimeters. So this is a very simple way of knowing how to multiply one thing by the number you got to get the thing in the unit of measure you want. It's a very, very simple way of doing that. So I will urge you to have this book on hand. Or you can Google it. The good thing about this book is it covers a wide range of things, some of which Google doesn't cover. In fact, when we dive into some of the quizzes I've given you, you'll find that Google doesn't always do the full job, though Google is getting better and better each year. So who knows, by this 3rd year I've been teaching this course, Google might actually do the job.